Hello, hiya. Here's our starter for us. So we've got 4 questions. First question, I want you to draw 2-methyl butanol and decide whether it's a primary, secondary or a tertiary alcohol. Question 2, I want you to name and draw the functional group of aldehydes and ketones. Question 3, I want you to name this molecule. Question 3b, I want you to name that molecule. And then question 4, I want you to draw 2,3-dimethyl butanol. Okay, so as usual, pause the video, complete the starter. I'm just about to go over it, okay? Right, question 1. Draw 2-methyl butanol and decide whether it's a primary, secondary or a tertiary alcohol. So if we draw that as butanol, so that's 4 carbons, 1, 2, 3, 4, with the OH on the second carbon, and we've got a methyl branch, 1 carbon, on carbon 2. So that looks like that. And then if we just put our carbons in, if we just put our hydrogens in, that is our molecule here. And when we're deciding whether it's secondary, tertiary or primary, we find the OH group and then we focus on the carbon that's attached to, okay? Then we focus on the carbons that are attached to that carbon. So we have 1, 2, 3 carbons attached to the carbon that's attached to the OH group. So this is a tertiary alcohol, okay? Question 2, name and draw the functional group found in aldehydes and ketones. So that's a brand new functional group. So that is the carbonyl group, okay? And it's the C double bond O with 2 bonds coming out it, okay? Question 3a, name that molecule. So again, we start from the side closest to the functional group. The functional group is bang in the middle. So we then start at the side closest to the branch, which is there. So that is 1, 2, 3, 4, 5. Okay. You'll notice it's got a carbonyl group. Okay. And because the carbonyl group is in the middle of the molecule, it's between 2 carbons, this is a ketone. Okay. You need to be able to recognise that. If this carbonyl group was found at the end or the start of the molecule, we would call that an aldehyde. Okay, so because it's a ketone, we then start naming it. Now it's got 5 carbons, so that's pent. Okay, and the carbonyl group's found on carbon 3, so this is pentan 3-one. And the only reason that we are numbering where the carbonyl group is because it's bigger than, the straight chain's bigger than 4 carbons. Remember, it goes propanone, butanone, then we need to start labelling the number. So pentan 2-on, pentan 3-on, so on. Okay, and because it's got a branch on carbon 2, this is 2-methyl pentan 3-on. Okay, right, now this one here, identify the functional group. Hopefully you never thought this was an aldehyde. Okay, this is sort of a trick one. This has got it's got the carboxyl group. Okay, because it's C double bond O OH. So this here is a carboxylic acid, and because it contains 2 carbons, 1, 2, this is ethanoic acid, aka vinegar. And that's it. So hopefully you said that was ethanoic acid, not ethanol. Question 4, draw 2,3-dimethyl butanol. Okay, so this is an aldehyde because it ends in anal. So 4 carbons, 1, 2, 3, 4. Carbonyl group at the end, okay, because it's an aldehyde. And then we've got a branch on carbon 2, a branch on carbon 3, and then the rest, quite simply, are hydrogens. Okay, there it is, 2,3-dimethyl butanol. try not to get confused with a carbonyl group in an aldehyde and a carboxyl group in a carboxylic acid. Very common mistake. Right. What we're going to do is we're going to start looking at oxidation. Okay. Now, Mrs. Clark went through this with you on Friday, but I'm going to just give you the note on it. I'm going to recap it. Okay. Now, first things first, we need to know the definition of what oxidation is, and oxidation does mean the loss of electrons. Okay, if you think back to National 5 oil rig, oxidation is loss of electrons, but in this case, in organic chemistry, when we're dealing with sort of carbon compounds, it means there is an increase in the oxygen to hydrogen ratio. Okay, now I'll give a quick example. Okay, I don't want to spend too long on this because I'm going to come back to it when I eventually get back to school. So let's just say we go from ethanol to say ethanol. Okay, so we're going from an alcohol to an aldehyde. Yeah, maybe do this a different pen. The oxygen to hydrogen ratio, we've got one oxygen and we have 1, 2, 3, 4, 5, 6 hydrogens. The oxygen to hydrogen ratio here, we've got one oxygen, but we've only got 1, 2, 3, 4. So, compared to oxygens in this one, we've now got more oxygens compared to hydrogens here than we do here. Okay, I know we've got one oxygen each, but because we've got less hydrogens, that means that we've got more oxygens in comparison to hydrogens. But like I said, don't worry, because I'm going to go over it in a lot more detail when I get back. Okay. Right, I'll carry writing on in the blue pen actually, it's clearer. So, we can use oxidizing reagents in order to oxidize alcohols. Okay, and that's all an oxidizing reagent is. It's just something that oxidizes something else. Okay, but again, we'll go into a lot more detail when I get back. Now, what Mrs. Clark taught you is that primary alcohols can oxidize. Okay, secondary alcohols also oxidize. Okay, however, tertiary alcohols, they do not oxidize. Okay, and that there is very important. Okay, as is, by the way, the definition of oxidation, because you can be asked what is meant by oxidation. Okay. Right, so primary alcohols, they oxidize, secondary alcohols, they oxidize, tertiary alcohols, they do not oxidize. That's what you should have got from the lesson on Friday. Now, what I'm going to do, I'm going to go into more detail about each one, okay? What do primary alcohols oxidise into, what do secondary alcohols oxidise into, and, well, obviously tertiary alcohols don't. Now, if we start with our primary alcohol, if we oxidise that, okay, now I'm gonna, this is a wee sort of shorthand way of saying goes through oxidation, so that there just means we're going through oxidation, okay, so the wee O in square brackets just means we're going through oxidation. Now, we need to use an oxidizing reagent. In the case of alcohols, Mrs. Clark used two. We can either use copper oxide or acidified potassium dichromate. Okay, so that's our two oxidizing agents. We can either use copper oxide or we can use acidified potassium dichromate. Okay, right, if we do that, okay, if we oxidize a primary alcohol, that goes to an aldehyde. Okay, and you need to know that if it's a primary alcohol, it oxidizes to an aldehyde. Now, what we can then do is we can oxidize the aldehyde again, and if we did that, it would oxidize into a carboxylic acid. Okay? Now, you need to know that. You need to know that alcohols can be oxidized into aldehydes, which can then be oxidized further into carboxylic acids. Okay? Right, now, what do secondary alcohols do? Okay? Now, again, there's a wee O to show that it's oxidizing, it's undergoing oxidation, and the reagents, the exact same, see above for oxidizing reagents, so that is your copper oxide or your acidified potassium dichromate. Okay? That's your two oxidizing reagents. Now, primary alcohols oxidize into aldehydes. Secondary alcohols, can you think what they would oxidize into? Ketones. Okay? So, they oxidize into ketones, and this is quite interesting. If we try and oxidize a ketone, nothing happens. Okay, we can't oxidize a ketone. So secondary alcohols oxidize into ketones, and that's it. Okay, they can't go any further. That's the only thing they'll oxidize into. And tertiary alcohols, we've already spoke about this. If we try and oxidize them, nothing happens. We can't oxidize them. Okay, so this here is the basis of oxidation. Okay, you need to know this off by heart. Okay, you need to know that primary alcohols can be oxidized using copper oxide, acidified potassium dichromate, into aldehydes. Aldehydes can then be oxidized into carboxylic acids. Secondary alcohols can be oxidized into ketones, but that's it. And then tertiary alcohols, they do nothing. Okay, so it's very important that we know how to identify a primary, secondary and tertiary alcohol, and we've been doing that this last few lessons, and you need to know how to draw aldehydes and ketones, essentially. Okay, and then in turn, carboxylic acids. Now, the SQA aren't just going to give you the question, what do primary alcohols oxidize into? They'll give you an alcohol. You need to work out what type of alcohol it is, and then you need to draw it yourself. Okay, so let's start looking at examples. So let's go for propan 1O. Okay. So if we draw that out, 3 carbons because it's prop, OH on carbon 1, and the rest are hydrogens. Okay. Now, you need to work out what type of alcohol this is. So again, find your OH and then look at that carbon that's attached to, and then how many carbons is attached to the carbon that's attached to that OH group, and you should just realise that it is 1. Okay, so this here is a primary alcohol. Okay, we know it's an alcohol because it contains the hydroxyl group. We know it's primary because there's, the carbon that's attached to the hydroxyl group is attached to one other carbon. So this is a primary alcohol. Now, if we go back, okay, primary alcohols, they oxidize into aldehydes and then carboxylic acids. Okay. So, what happens here is when we are undergoing oxidation, the alcohol loses 1, 2 hydrogens. Okay, so if we oxidize it, it's losing 2 H's. Okay. And if we draw it out, we've still got 3 carbons, 1, 2, 3, but because we've lost 2 H's, there has to be another bond to that oxygen, so we get a double bond O, and then we've still got that H left there. Okay, we fill in the H's, and there it is. Again, our functional group is C double bond O, which is at the end. Okay, it's a carbonyl group, it's at the end of the molecule, so this is an aldehyde, yeah, because we've lost 2 hydrogens, we've created an aldehyde, so this is propanal. Okay, and this is what the SQA will do. They won't tell you it's a primary alcohol, they won't tell you that it oxidizes into an aldehyde. You need to know that, and then you need to name it accordingly. Okay, now it doesn't stop there. Okay, it can oxidize again, and if it does, this time we add an oxygen. Okay, and the oxygen goes between the C and the O. Okay, so we get an O and in between the H as well, so we get an OH. We've still got the carbon to carbon double bond, the carbon to oxygen double bond, and fill in your hydrogens, and what we've now got is we've got a carboxyl group, which is a carboxylic acid, so we've now got propanoic acid. okay? So, and that's what happens during oxidation. If we're oxidizing an alcohol, we lose 2 hydrogens. If we're oxidizing an aldehyde, we're adding an oxygen between the C and the H. Okay, and that's it. Now, if we go for propan 2-ol, yeah. So again, exactly the same as propan 1-ol, just the hydroxyl group is now on carbon 2. Okay. And again, if we oxidize an alcohol, the first thing that happens is you lose 2 hydrogen. Okay, and the 2 hydrogen that you lose the H of the O, the H attached to the O, and you lose the H in the middle. Okay, you lose the H that's attached to the C that's attached to the OH. Okay, so what we're left with is that. Okay, now the O needs to have a double bond in order for the valencies to match up. Yeah, valency of carbon's 4, and that there is your carbonyl group, and because it's in the middle of 2 carbons, it's a ketone, so you need to name this accordingly. It is propanone. Okay, there is no number because there is only one position that carbonyl group can go, and it's bang in the middle, so we just call this propanone. Now, the reason we can't oxidize it, if we look at the primary alcohol, yeah, the H attached to the carbonyl group gets an O inserted in it, but if you look at the ketone, there is no H attached here, so we can't add an oxygen, and that is why it doesn't oxidize any further. Okay, now I'll keep it with propanol. Let's just go for 2-methyl propan 2-ol. Okay, again, obviously this is a tertiary alcohol, but again I'll show you why. Find the OH, look at the carbon that's attached to the OH, and then how many carbons is that attached to? It's attached to 1, 2, 3. Okay, or maybe, so propan 2-ol was a secondary alcohol, 2-methyl propan 2-ol is a tertiary alcohol. Okay, now the reason this isn't oxidizing, again, when we try and oxidize an alcohol, we need to lose 2 hydrogens. Okay, now if we look at this, we could lose the H that's attached to the O, but there's no hydrogens attached to this C here, and because there's no hydrogens attached to the C, we can't oxidize it. Okay, and that's why tertiary alcohols don't oxidize. So you need to know, the SQA aren't just going to make it easy for you. They'll give you an example, they'll give you an alcohol, and they'll say, what does this alcohol oxidize into? So the first thing you need to do is identify the type of alcohol. Once you've done that, you need to have this memorized. So if it's a secondary alcohol, it oxidizes into a ketone. If it's a primary, it oxidizes into an aldehyde, which can then be oxidized further into a carboxylic acid. If it's a tertiary alcohol, nothing. Okay? Right. Now, going to give you a wee question here, so write this down. So name the type of reaction. Now this question here is very, very sneaky, okay? But I like it, okay? And this is what they'll do to you. Okay, so they'll give you this. This will be the question. It will be name the type of reaction. Okay, now when you get questions like this, the first thing you should be doing is you should be identifying what the functional groups are in each one. Okay, now looking at this question, hopefully you see that's a carboxyl group and that there is the carbonyl group. Okay, so because that's a carboxyl group, this is a carboxylic acid, and because that's a carbonyl group and it's at the end of the molecule, yeah, that is an aldehyde. Now, a lot of people just instantly think, oh, oxidation, but be careful, okay? If we look back onto this, aldehydes and carboxylic acids, if we go from an aldehyde to a carboxylic acid, it's oxidation. But look what's happening. We're going from a carboxylic acid to an aldehyde. So we're going, again, if we go back to this, we're going the opposite way. Okay? And this doesn't, for some reason, it never really clicks in. But if going from an aldehyde to a carboxylic acid is oxidation, if we go from a carboxylic acid to an aldehyde, if we go the opposite way, what do you think it is? It's reduction. Okay? So, you need to be careful. Yeah? Going from a primary alcohol to an aldehyde to a carboxylic acid, that's oxidation. But if we went from a carboxylic acid to an aldehyde and then an aldehyde to a primary alcohol, that's reduction. Okay? And you have to be very careful. Try not to get confused with that. But don't worry, I'll give you more examples of that in a while. Right. I'm going to do one more and then I think that will be us. So draw this, I'm drawing 5 carbons and I'm drawing an OH on the second carbon. Okay, so this would just be show what happens when the following alcohol undergoes oxidation. Okay, so first things first, we'll just name the alcohol. 5 carbons on the second one, so this is pentanetol. Okay, find the OH, look at the carbon that that's attached to, and then how many carbons is that attached to? It's attached to 1 or 2. So this here is a secondary alcohol. Okay. Now, if we oxidize that, sorry, that's the question. If we oxidize pentanetol, okay, it's a secondary alcohol. If we go back to our wee sort of sheet, secondary alcohols go to ketones. Okay, and again, how does it do it? It loses 2 hydrogens it would lose that hydrogen attached to the H, and it would lose that H attached to the carbon. Okay, and if we draw this, it would be 1, 2, 3, 4, 5. Get your other H's in. And we've lost that H, so we're left with a C double bond O. That's our carbonyl group. It's in between two carbons, so it is a ketone, and if we were to name this, this would be pentan 2-one. Okay, remember we need to state the number of it because it's larger than 4 carbons, so yeah, carbon 2, pentan 2-one. If we try and oxidise that further, because it's a ketone, nothing else can happen. Okay, now I like this question. If that's 5A, 5B, draw, again, this is SQA bringing in that 5 stuff, and they like to do this. Draw an isomer of pentan-2-ol that would not oxidise. Okay, so it wants you to draw an isomer of pentan-2-ol that would not oxidise. Now, pentan-2-ol is a secondary alcohol. If we drew a primary alcohol, that would oxidise into an aldehyde and a carboxylic acid. If we drew a tertiary alcohol, that doesn't oxidise, so that's what we want. Okay, so we want to draw a tertiary alcohol. Yeah, because they do not oxidise. So again, remember a definition of an isomer. Isomers are compounds that have the same molecular formula but different structural formulae. Okay, so we need to draw a tertiary alcohol. So what I would do is I would take it to 4 carbons in the longest chain. Okay, put the OH on the second one, and because it's an isomer, it has to have the same molecular formula, so we've got 5 carbons, so we need to have 5 carbons here. So I would draw my 5th carbon right there and fill in the rest with H's. Okay, so again, we've got the same number of carbons, 5, 5, same number of O's, 1, 1, same number of H's. So it is an isomer, and it's a tertiary isomer because there's the OH, there's a carbon attached to the OH, and that carbon is attached to 1, 2, 3 carbons, so that there wouldn't oxidise because we can't lose 2 H's. We can lose 1 H there, but we can't lose a H because there is no H attached to the C, so this doesn't oxidise. So that's it. Okay. So that's everything there. I'll put up some work on Teams for you to do, but that should probably take you the full period, and I will see you tomorrow. Thank you.